Bonjour. Hi, everyone. Thank you for being here. And I want you to know that I'm very, very happy to be here, to share, to discover Groundswell. It's a marvelous event. I wish we could have that in Quebec. Talking about Quebec, this is why you're going to hear that weird French accent for the next hour or so. And so if ever I say words you don't understand, it's only because I slipped a French word in what I try to be in English talk. So we're going to be talking about the secret of soil profile. What I do in Quebec, I work mainly with farmers. How many farmers is there here? Great. And so my talk is really directed to farmers. And yesterday, when I gave a talk, I talked a little about compaction, and I want to start with a bit of that compaction talk to get into the secret of a soil profile. Okay with all of you? Okay, and I need you to respond. I really need you to give me a sign that you're still there. Because if you don't, what happens in my mind is I can't start talking in French. Okay? Is that okay with all of you? Good. I see that you don't want to hear any French today. When we talk about agriculture, and it's always the same, it's what we see, and it's perfectly normal thing. And what we see here is a very, very well looking cover crop field. But the way I'm working all the time is I get to this farmer's, and he's really, really proud to showing me his field. And guess what I do? I dig. And guess what I found? 90-degree root system. And then he just said, well, it a rock. And then I keep digging, and I find that all of the time. And that is only showing that what we see is not what is really happening. And we need to go to that soil profile to understand it better. Compaction is acting on two sides. It is acting on the surface, and it is acting at the subsurface as well. When you have the surface compaction, you can get as much as 95% less root system in your field. And these are the roots that, of course, we're always saying that 80 to 90% of the root system are within the first 30 centimeters or so. But if you're lacking 90% of these roots to begin with, you cannot have the root system that will go deeper. And this is a root system of a wheat crop that is in a good soil. And you can see that down to 1 meter, you still have about 5% of the root system there. And in a drought situation, that 5% of the root system can provide up to 20% of the water that the plant is needing. So I really want to work on that compaction thing as well. The surface compaction is directly related to the air pressure in the tire. And as you can see here, from different air pressure tire, you can see the difference in the amount of water that is getting in this, not the amount of water, but the amount of weight that is applying to the soil. So you see this difference there. The tire sinks a little bit more, and the slope that the tire has to overcome is also pushing a bit forwards to compaction. But we don't really see it. But this is happening, and this is why we're having trouble with the surface compaction. And you can see here, same tire, same weight on the wheel. A 9 pound, I'm sorry, you work in bar, right? No, you work in, oh, you work in PSI. Oh, you're like Canadian. Yes, we conquered you. No, I'm sorry, that's the other way around. So So it's a 9C versus 23C that represent almost 40% more surface area at the soil surface. So it does mean a lot to a surface compaction. So we do have to think about the air pressure in our tractor. And the second thing is the subsoil compaction. And this is a kind of a situation I get into. We have that tractor and we have that manure spreader. And what we do is we weigh. I have big weight in the trunk of my car, and I weigh tractors all the time. And so you can see that in the front wheel, you have about 2 tons. The back wheel of the tractor, it's about 4 tons. And the wheel of the manure spreader is 5 tons per wheel, not per axle. We're working per wheel now. And so what it does, and what you could see also is that the red numbers is the air pressure that the farmer put into his tire, and the green are the one that I calculated, and they're safe air pressure. It's not out of my mind and because I like low air pressure, but they're real secure air pressure that you could put in your tire. And so what it does, what you see on your left is the impact in the soil from the compaction due to the weight of the tractor with respect to that 24C and the 13C is, 6C is the air pressure in the tire, and the amount of the impact at the soil surface is 13C, where it's 6C. C or psi? Pound. PSI. Thank you. I'm talking to you now. This is all for you. So when I put 6 PSI in the tire, I imply 13 PSI at the soil surface. And when I put that 17 PSI from the farmer, it's 24 PSI that is implied at the soil surface. And you could see, and what I want the most at the soil surface is that yellow band. And when it's 17 PSI, then I get to have the beige one and the orange one. And this is way too much for the soil surface, and this is impacting. And the other thing that you see that it's the line, the 7.25 PSI line, is the amount, the maximum amount I want to apply in the soil at 50 centimeters deep. And so in that case, with 2 tons per wheel, I'm okay. But as we go along, you'll see that we increase the impact at the surface, and we also increase the impact at depth. So I need to understand that. We need to lower the air pressure to protect the soil surface, and we need to find ways to have lower weight per wheel in order not to go across that 50 centimeter line. And so one thing, and the other thing is also the impact on bulk density with respect to the water humidity of the soil. So we always think that if we work in a dry situation, we are going to impact less our soil. We have the feeling that it has a better bearing capacity. It does. So that's what it showed here. But at the same time, all the weight has to be supported. You know, I'm always comparing that to a boat. You know, when you buy a boat and it says it has a 14 feet reach or whatever word you use, it means you need 14 feet of water so that the boat's not gonna, that it's going to be okay. Do you use boat? Do you know what I'm talking about? Okay. Sometimes things they're going faster in my head than with the English word. So it's the same thing with the tractor. The tractor needs a certain volume of soil to support it. So if it's very dry, it's going to need less volume, but the impact is going to be greater. So that's why the impact on the bulk density in the dry situation is a lot more important than in the right humidity in the middle one. And when it's wet, you see that the impact goes deeper. So we need to go in the field at the right humidity as well. What would be that humidity? French coming. It's when you go in the field with your tractor, and it doesn't leave any mark, but at the same time, you have the soil that will go all over your tires. If the soil is too dry, it's going to go right on top of it. It's not going to go around all the you understand what I mean? Good. I even in French, I have difficulty to do that. So if I go from one axle to two axle, then what I see is I split into two the impact of weight. So the first thing, air pressure in your tire, and then the second thing, you have to look at diminish the weight per wheel. And you can see right now the impact that it does at the soil surface and at depth. So we have to think about it all the time. Does that make any sense to you? Now let's start the real 55 minutes. I want to talk to you about soil profile. How many of you have been doing soil profile? How many times a year do you do soil profile? Frédéric, you don't have the right to answer that. There's one guy at 10 there. Are you a consultant or a farmer? Both. Okay. How much time do you spend taking care of your tractors? You don't take care of your tractors. In Quebec, it could be hundreds of hours a year. Does that make sense? Okay. How much time do you spend doing soil profile? It should be the same answer. I'm always saying, you can farm without a tractor. You cannot farm without land. And yet we have to spend more time trying to dig and touch for the first. Why we're doing it? We're doing it to understand. For the past 2 days, I've been hearing about soil biology, about cover crops, about minimized disturbance. I've been hearing that all, and I've been saying it for the past 30 years as well. But we find out that if we don't know what's going on in your soil profile, it won't be easy to adopt or choose the right strategies so that we can move on easily. The thing that I hate most is when I talk to a farmer and he comes to me and he says, I'm going to get into no-till. I know I'm going to have a yield loss. If you have a yield loss, it's because it's not the right strategies. If you have a yield loss in trying to do something, it's because there's something that we didn't understand in making the transition. We have to avoid these yield loss. Usually a yield loss means we're going to go back to that comfort zone I was showing you before. We need to make sure that every step we make is a strong one that's pulling the back leg forwards. So we do it to understand where do we do soil profile? Always 2 soil profile at a time. One in a good place in our field and one in a bad place. We need to understand what's going on. Same field, same crop, same sky, same rain, same soil, and yet we're having difference. By doing it where it looks good and where it looks bad, it gives us the comparison that we need to do. When? I like to do my soil profile when I have roots in the system. So mainly August, September, October. But more and more, we're doing it in May, June, and July, because there's more and more farmers that wants to learn how to do it. And who? With the farmer. The farmer. Every time I do a soil profile, I want the farmer to dig. I want you to know that the first step in soil profile is the knee test. And if you've been doing soil profile, you've been experiencing that, right? The knee test. When the knee hits in, it's the moment where you become a root. Did you feel that? Oh, you're not sure. Now you're thinking, oh, crazy French lady. How much more time can I leave without her noticing? I'm looking at all of you, learning all the names. The knee test. when it's getting hard, you know that a root is not going to be able to go there. It's telling us a lot. It's telling a lot and not a lot. So when I do the soil profile, there's 4 things I want you to remember. But if you've already done it, it's going to be an easy part. We want to dig and we want to touch. So the first thing we're going to look at is the color and the odor. So when you're doing your soil profile, do you smell your soil? Yeah, does it smell good? Have you ever experienced a soil that when you reach to your nose, the arm goes away before you smelled it? I did. Soil porosity, soil structure, and the roots that we're going to be looking at. The first thing we're going to do is we're going to split the horizon, and we're not going to do it in a pedology way. We're doing it in an agricultural way. And the second thing I'm going to be doing is I'm going to take my knife, and I'm going to put this knife at the bottom of my soil profile, and I'm going to go up with it. What is it going to tell me? Where's the compaction? Is there any sorts of compaction? And I need to know that where it is. Then I keep pulling, and at one point it can become easy again because there's a way where the roots are more and where I'm working. I need to have those 2 spots in my soil profile, and this is going to be an horizon I'm going to be studying. So this is what I'm going to be doing. And for the fun of it, 1 time out of 2, when I give my knife to a farmer, he breaks it. I don't know how you do it, guys. But it's just, I think it's too much pride. You get in that hole, you put the knife right into it, all of it, and then you want it to get out of it. And then you only go out with the handle. I'm sorry. So if I go to do a soil profile at your place, don't be mad if I don't give you my knife. Bring your own. Color and odor. What color is the soil I'm looking at? Of course, when I'm starting, it's brownish. I want it brown and as deep as I can. And this is the kind of color I would get in Quebec. Sometimes I get to grayish zone, and then I want to have this orange part that shows me that the water is flowing right. You have some soil profile here. And this is a good one. This is a bad one. And you see all this little mark I'm putting in, this is what I'm going to be studying. And so what you can see is sometimes it's easy to determine the horizon I'm going to be working with because I'm going only by the color, because as I was doing my knife thing, everything was going fine. But in the second one, you can see that the second layer there has both the brownish color and then the fader brown color. Do you see that? Okay, please don't forget, French is never far. And so that means that in that little zone there's a compacted layer. So this is what I'm going to be observing. And again, we have a very nice soil profile here. You see that the colors are getting quite different, but it's a very nice soil profile. And for the last one, again, we have a very bad soil here. And you could feel it. I could feel it because I dig it and I did it all. But the second horizon there is also an horizon that's very difficult and that we'll have to look at. And that is only showing that with these 4 soil profile, the strategies I'm going to be putting on are going to be completely different. And I need to know more about that. Then I want to look at the porosity. I want to know if these soil have spaces in it so that the roots can grow. Is this micropores? Are there any big micro and macropore? And I want to look at that, and I want to know that. And everything I'm saying, I'm doing it for every horizon. I'm taking notes for all of that all over the place. And then I look at the structure. Can you see that structure here? Very laminar structure. So you can see that this soil will be easily compacted. It's like a bunch of sheet of paper on top of each other. So I need to understand that. I want to know that so that when I think about tractors, when I think about weight, I think this soil is very vulnerable. See that structure over here? It's the same. And then we get to better structure. And this is one thing we do afterward. After I've looked at it, I will take a piece of soil in my hand and I will break it with my thumb. I'm not crushing it over and over. I'm doing only once or twice, and then I see how the crumble looks like. So if they look like something very, from the left one, which has different size of aggregates, then I know that the structure is not too bad. But then if I look at the other one, which has only big clump, then something is the structure there is a bit too coarse. Does that make sense? So I want to look at the color and odor. I want to look at the porosity. I want to look at the structure, and then I'm looking at the root system. Are the roots growing downward? Are they round? Are they white? Are they having fun? Do they feel something wrong somewhere? I'm sure the farmer where I took that picture wouldn't be very glad that he's now in England. But, are they flat? This is really interesting. Every now and then I would go and I have flat roots that has little roots that goes only 0 to 180 degrees. It doesn't go around. So it means I have a very coarse structure. I have a very high compaction level. And so I write all that down. And then the next step is the dynamic characteristic. As I read through my soil, I looked at it, and this is the qualities that I find in my soil. Then I have to quantify it. I've been talking to you about compaction, and now I need to know how intense is that compaction. What is the strategy that I can be using for? That root that I showed you, it happened just about 3-4 inches at the top of the soil, meaning that this was seeding in a very humid area. And we only need a soil, working the soil at about 6 inches, and we will have corrected it. But I need to know that, and only the soil profile is giving me that. So there's a lot of things that I can look at. And what I'm doing is everything that I'm showing up to now and until the end is things that you can do at your place. I want farmers to be able to look at these numbers and to be able to do it at their place. You can do it with a laboratory if you want, but I'd rather have you do it at your place. So it's simple stuff. We're going to be looking at infiltration, structural stability, bulk density, and microbial life. To do the infiltration, you need only 2 cylinders, 6 inches and 4 inches, which is 15 centimeters and 10 centimeters diameter. And we've been doing that with that. And for a few summers, I had students that were doing it with that and with the very sophisticated laboratory material. We get the same answer. We get the same answer. So you go in the field and you place the outer one and the inner one, and you fill with water in between the two. You let the water get in the soil, and then you refill the outer cylinders as long as it's gonna fill the inner centers. And then you count the time that it will get in. In that place, which is quite a big soil profile, this farmer wanted to put drain back in his field because the infiltration wasn't going right. And so we were there, we took the infiltration at the surface, and it took an hour and a half to get 2 centimeters of water in the soil. And then we did it at 40 centimeter deep, and it took 8 minutes. So it had nothing to do with drainage. It all had to do with a compacted layer that we find. And if this guy had done his soil profile before calling the drainage, then it would have cost him $20,000 less, which he would not give to me anyhow, even if I made him save it. We still talk, but I'm charging first. Infiltration is something very important because it's going to tell me about the water movement in the soil. And the water movement in the soil is also going to tell me about the water holding capacity in my soil. So on the left, you see a very high quality, healthy soil, and on the right, you see a poor. And what we can expect is that on the right, it's a plowed soil, so you have the top surface that is really with a lot of air, and you can fill in with a lot of water, but there's nothing going down the soil profile. More, if you look at the right one, once the top part is going to be filled, then the excess water will have to go out by evaporation or running off. And therefore, you're losing water to be able to replenish your water holding capacity. So if you look at a very poor soil, then you see that you have a poor infiltration, the water raise will be low, you can even have, they call it hypodermic flow, a poor capillarity as well. We want the water to get in the soil so that it can go back to the plant. To be able to go back to the plant, there's two roads. What are the two roads that a water can take to go back to the plant? The roots are the first elevator, and the capillarity of your soil is the second one. And if the capillarity is continuous, then it's going to go from bottom to up. In that case, it's not, so we're losing a lot of that water. Otherwise, if we have a well-structured soil, well, then you see the difference that's going to be happening. The water is going to go down. It's going to rise your water table, so I still have a lot of water in my soil. This is where I want the water to be. Then the capillarity is going to be working, and the plant is going to be able to take. This is a very healthy soil. What's happening in a healthy soil? What is the amount of water available to plant in your soil? You have your soil, it's full capacity. How much of that water will be taken up by the plants? Yeah. I'm sure, yeah, you're right. But what the big difference between clay and sand is the amount of water holding capacity. Yeah, but that water that's been held, 45%. Just about 45%. Good person, two. That's good that you're two together. I like it when I ask question and the answer is on the board and nobody's answering. It's just like, wow, there's but it's okay. It's the same in Quebec, and it's even worse with students. You know, younger they are, less high seeing they're doing. But if you have a very healthy soil, you're going to have a lot of microbes and a lot of fungi in your soil. And these fungi, these mycorrhizae, are able to go and pick up again at 25% more of that water that's being held in the soil. So I need to understand that, a very healthy soil is really efficient in all of these management. The next thing I'm going to take is the bulk density. Very easy, a cylinder of known volume, at least 180 centimeter cubes, and I take that in the soil, and again, I'm going to take it in every horizon. And it's going to tell me stuff. It's going to tell me the intensity of the compaction I've noticed in the soil. So I'm doing that, take the soil, bring the soil home, dry it, very easy. These things you can do at your place as well. You take the soil, you make it dry, make it in your microwave, take the weight, 30 seconds in microwave, take the weight, and if it's the same weight for 3 times, then you have a dry soil. Divide the dry soil by the volume of your cylinder, it's going to give you the bulk density. And again, with respect to the type of soil that we have, the bulk density is going to be different as well. So what we know from science also is that we have different bulk density that we should be aiming at for different type of soil. And you could see here my little French part, right? Sometimes I get lazy and I don't translate everything. But the first column, it's the bulk density that I want to look at. The second column is telling me, whoa, at that point, roots are going to slow down. And the third column is telling me that at that point, roots are not growing anymore. So by doing my bulk density at different horizons, then I know, is it a bad compaction, a very strong compaction, and it will also define the strategy that I'm going to take. Are roots going to be able to deal with that, or should I get in with a subsoiler? And then we can talk about subsoiling for a little while if we have time. And then the aggregate stability. We looked at the structure when we started. And now I want to know, is this structure stable? And we can do that with water. You've all done that, right? You've seen that. It's yes. Yes, somebody says, yes, say something. Yeah, it's the slightest. It is. But we can do it. And we can do it with different ways, and you can find out. But just do it, and you can have a good idea of the structure that we've just seen in the soil profile. What is its stability? So soil profile, dig and touch, and then we are there to observe and measure at the same time. And I want to look at the microbial life. Okay, and you've all done that, right? You've done the underwear test. Now you're thinking of a test that you can do with an underwear. I'm talking in the soil. Come back here with me in the soil. So it needs to be in 100% cotton, and you need to put it in the soil. And cotton has about the same carbon to nitrogen ratio than microbes. And so this is why they're going to attack it and like it very much. And so as you're doing it, you're putting it in the soil. I'm always putting them for about 8 weeks. And whatever you do, these kind of experiment, just make your own protocol. If you put them June 15, take them out August 18, then you do it over time, all the time. It's just 1 year, June to August, and the other year, July to September. Try to always put them at the right time to have the right comparison all the time. And then you can see that in a very poor soil, compacted soil, this is what I get out after 8 weeks. And in a very healthy soil, this is what I get out. It all comes back to the sun. How much time do I have left? 50? Good. My English, my earrings not that good. It all comes back to the sun. We are always saying that we need to harvest the sun. We need to take all the advantage that we can get from that solar energy that permits the photosynthesis to go on. And that photosynthesis is feeding our root system, which in turns will be feeding the plant. But as it's doing so, by feeding the microorganism, these microorganisms are producing what we used to call glomalin. For the past 10 years now, it's changing word. Because you know about glomalin, right? You know all about glomalin? Okay, glomalin is a protein type excrement, exudus produced by the microorganism. And this is really a glue. And for many, many years, it was said that the glomalin was produced by the mycorrhizia. But over the past 10 years, the researchers find out that this is also produced by all the microorganisms that lives in the soil around the root system. And this glue is very important because this is going to glue together the soil particle and the organic matter material to make it very stable. So remember, we looked at the structure when we did the soil profile. Then we looked at how the stability of these aggregates were. How can I improve because from what I measured, now I want to put in some strategy to improve where I had some weakness. Does that make any sense? Are you following me? Okay, so if I have a poor aggregate stability, I need to improve it by putting some more glue into it. And the glue is produced by the mycorrhiza, that the microbes, microorganism that lives around the root system that are feeding it because of that photosynthesis that comes from the sun. Okay, sun photosynthesis, carbon microorganism, production of that glomalin type of glue, and so on. How long does that glomalin last in the soil? Say something. Don't know. Good. Just about a month, few weeks. It doesn't last long. And this is why the cover crops and the root strategies are becoming so important, because they're going to be the bridge in between the roots of our commercial plants that we're putting on. This is why we have to think about these root systems to improve our strategy. The other thing is we are always talking about organic matter, and this is the data that I like to show as well, is when we started to do no-till, it was to protect soil, to cover, to avoid erosion, but we were also saying that the organic matter produced, all these residue on top of the soil will increase the organic matter in our soil. But the searchers have found that only 8% of the carbon in the residue on top of the soil will become organic matter, soil organic matter. Only 8%. Why is that? There's so much organic matter, there's so much carbon in these residue, because their carbon to nitrogen ratio is so high that the microbes will feed on that carbon. They will take that carbon as an energy to decompose these residue, leaving only about 8% that will at the end become soil organic matter. But if you have cover crops, green cover crops, if you're using manure, 12 to 23% are going, this 12 to 23% of the carbon content will become soil organic matter. And then in the roots, 45% of the carbon in the root system will become soil organic matter. So if you want to increase the organic matter of your soil, which will in turn work also on the stability of your soil, on the water capacity retention of your soil, then we have to go through organic matter. And again, this root system is coming into mind. I'm just showing here to you corn and wheat and ryegrass, which are three grasses that we can grow. And you could see the difference in the root architecture at the same time. And so this is also one thing that we have to look. I'm talking about roots, but then we have to think also on the diversity of the root system. At 60 centimeter deep, 44% of the roots will share the same path. So, did I tell you that 80 to 90% of the roots will be at the first 30 centimeters in the soil? But that leaves 10 to 20% that can go deeper. At 60 centimeters, they will share a pore. And at 60 centimeters, they will only grow if there is a pore in the soil. They are not strong enough at that depth to make their own way. They need to have ways there. So again, there's two ways to have pores at that depth. What are these two ways? Excuse me? Earthworms, yeah, earthworms and roots. Because as a root goes in, when it dies, the biopore that it will leave, if there's another root coming in, it will take it to make its way. And as we have all these roots going in all these root spores, then we're having that soil building up. So we have big roots And also, I like to show this picture, and now I don't know how much time I have, and then I start to talk very fast. But the roots, when roots go in the soil, it doesn't push the soil. It pulls it on top. Have you ever thought about that? We seem to think that there's a root system, and then it just like squeeze. No. As the root goes in, what it does, it takes the soil and pull it on top. This is why some of them, we can use them to avoid compaction. So if you have very tiny roots, we don't see that color. But with these big root system, if you ever go with radishes, for example, you can see at the top of it these color that they're making. And now I'm getting into cover cropping, and two things I want, I work a lot on is the why. We need to know why. Every crop we grow, every plants that are growing, they're having three objectives, okay? There are cover the soil, feed the organism in the soil, the microorganism, and recycle the nutrients in the soil. They all do that. I need to know the why the farmers are doing stuff. For example, if some farmer comes to me and says, I want to make money, what is it that I should grow? Corn, canola, wheat, okay? Now, I want to cover my soil. They all do that. I need to have the specific reason. I want to have a flowering field because my wife likes flowers. That's a good reason. And the why is then going to tell me the what and the how. I want to increase the organic matter in my soil. I'm going to look at very heavy root system. I want to improve the bearing capacity. I'm going to look at very heavy root system and also at the biomass on top of the soil. Do you understand what I mean? We need to know the why. We're not just planting cover crops because this looks good. We've seen a lot of cover crops. They've seen very wonderful thing. You've seen all of these cover crops with these big root system. Don't forget that they're growing, and I'm doing the same thing at home. We're making them grow in very heavy, easy soil. You need to know what's going to be best for your soil. The what? Legumes, grasses, legumes to fix nitrogen, grasses to make more structure, crucifer to catch the nitrogen, and the others to help the legumes to hold on, for the beauty of it, for the biodiversity, for everything. So we have four very big things. The owl, intercrop, catch crop after wheat. We have a very nice windows where we can put a lot of different, and we can work a lot on the biodiversity and the relay cropping as well. I have a farmer who did that, and when he explained to me what he was going on, he says, don't you think it's a little too much? He looked at me and he says, you told me to have roots in my system, and now I'm putting roots and you're complaining. That time I didn't charge. But what we're having here is wheat, winter wheat, where he left some spaces to plant soybean. And then he harvested the wheat, and then we had soybean that was growing into it. And in the fall time, he planted cereal rye, winter cereal rye into it. So, and you may ask, did he make money out of it? Yeah. He didn't have as much wheat. He didn't have as much soybean compared to a full field, but the two added together were more than the two single fields. So it's reinventing the agriculture that we're looking at. We are getting out of the way. Here I have a farmer who wants to have something in between his corn row, next year's corn row, that will control weeds in the spring. And he wanted to have his corn row to be completely clean. So this is what we did. We did crucifer on the row and grasses in between, and this is how it looked in the springtime. So you have the grasses, the cereal rye that is still growing, and then you had the corn that was be able to be planted. Then we took care of the cereal rye a little bit later. It looked like that, and within few weeks, you could see the corn really growing happily, and within 2 months, you could see all the earthworm that were making their middens, showing that there was still a lot of microbial life and life in that soil. Don't you like that? I find that really amazing what farmers are doing once they get out of the normal way of doing it. This is in an orchard I visited last week, and this is it was planted last year, these little apple tree, and you could see all the biodiversity that is occurring in between the trees. And 4 years later, it was in the same orchard, but he kept mowing it. So you could see he killed all the biodiversity just by mowing it. He's still having a lot of grasses, he's still having a lot of root system, but he killed the biodiversity. So last week I told that guy, stop mowing, just keep the flower. I'll see what it's going to happen. So that brings us back to the crop concept. This is one thing I want, I'm not going to have time to go over, but the crop concept for me is that whatever we do to get to soil health, the first step will always be the soil profile, to understand our soil, to meet sometime our soil for the first time. And then we need to have these 4 letters in place at the same time in order to be successful in our transition. And these 4 letters are for C for cover, R for roots, O for oxygen, and P for porosity, meaning we need to find ways to avoid compaction. So we need our soil to be covered in order to be able to resist the impact of water and wind. We need the roots to be in to feed the soil all the time. We need to find ways to marry our commercial rotation with the fertility rotation. The cover crops in the fertility rotation are not there just if I have time, if I find the right drone or white machinery or whatever. We have to think that these 2 rotations have to be taken care of with as much thought, and care than we're doing with the commercial crop. And then oxygen has to be everywhere, and porosity is, think about that compaction component. What is the AVS machinery? What is the way you're doing your work? Like I was talking about that with that guy with the track in the back there. I hope he's not here, but and he's saying I'm using the track because sometimes it's too wet to go in the field. So if you're going in the field when it's too wet, well then you're having a lot of problem with that surface compaction. This little one there is really good for subsurface compaction. He told me it weighs only 5 tons. So it's fine with me. But the surface compaction made with tracks is something really, really that we should take care of. So I guess my time is over. I'm very pleased to have met you, I hope. I help you a little. And forget about the French accent. Just keep on going and visit.